number 15, the last question. Which of the following statements is true? Part A, if a series has one or more factorials in it, we should always use the ratio test to determine convergence or divergence. Part B, if a series has one or more factorials in it, the ratio test is likely the best test for convergence or divergence. Part C, if a series has one or more factorials in it, then the root test is just as easy to apply as the ratio test. So the correct answer is going to be part B, and that shouldn't surprise us, because we should have a natural association between factorials and the ratio test. In general, when we see factorials, we should think about the ratio test. It's going to be better than the root test, as we'll see. However, saying always use the root test, that's a little bit too strong. Let me give some particular examples just to kind of demonstrate this. So for the root test, let's say we're thinking about the sum from n from 0 to infinity of n factorial squared divided by 2n factorial. This is a great test to use the ratio test on. When we do use the ratio test, this is a great test to use the ratio test on. We try using the root test instead. So we would want the nth root of this. I can drop the absolute value bars because everything in sight is positive. N factorial squared divided by 2n factorial to the 1 over n power. And I just don't have a clue how to simplify any of these things. 2n factorial to 1 over n power, n factorial to the 2n power. Take the limit of this as n goes to infinity. That just seems like a mess. So factorials and nth roots just do not play well together. If you thought about this long and hard, yes, there are some tricks that you can pull out in order to make things work in terms of approximations. I don't want to worry about that. The ratio test is going to be far better. So in general, when you see factorials, you should be thinking about the ratio test. The ratio test will very quickly tell you that this series is going to be convergent, absolutely convergent. That will be pretty easy to do. But when we see factorials, we should always use the ratio test. To say in particular, we should always use the ratio test. I can give a couple of examples here. So one example is, counterexample, I guess I should say, is the following. The sum of n from 0 to infinity of n factorial. Now this diverges. And in fact, if you use the ratio test, you'd show that it diverges, and it would probably take you 30 seconds to do that. However, if we use the nth term divergence test, instead of taking 30 seconds, we can take 5 seconds to do that. Just look at it. N factorial doesn't go to 0 as n goes to infinity, therefore diverges by the nth term divergence test. So I would argue that for this particular sum here, we shouldn't use the ratio test. We could if we wanted to, but it's faster, it's easier to use the nth term divergence test. Also, there are some cases in which you can have series with factorials in which the ratio test is inconclusive, but we can use other tests to figure out whether the series converges or diverges. An example of that, the sum from n from 1 to infinity of n factorial divided by n minus 1 factorial. Oh, sorry, that's supposed to be n plus 1 factorial. So if we apply the ratio test here, a sub n plus 1 divided by a sub n, absolute value of that, well, I can drop the absolute value bars because everything in sight is positive. This ends up as n plus 1 factorial divided by n plus 2 factorial. All of that over n factorial divided by n plus 1 factorial. And when we rearrange things, we end up with n plus 1 factorial squared. All of that divided by n factorial times n plus 2 factorial. And we are going to end up with, I'm going to skip the simplifying steps here. But we would end up with n plus 1 squared divided by n plus 1 times n plus 2. After rewriting, for instance, n plus 1 factorial as n plus 1 times n factorial, n plus 2 factorial as n plus 2 times n plus 1 times n factorial. And so this is n plus 1 divided by n plus 2. And the limit as n goes to infinity of n plus 1 over n plus 2 is equal to 1, so the ratio test is inconclusive. However, if we go back to this original series, if we just put in some simplification work first, n factorial over n factorial times n plus 1, cancel and cancel, and we just have the sum of 1 over n plus 1 from 1 to infinity, and this is a shifted harmonic series, so it diverges. So here's a case in which the ratio test doesn't do the trick, but if we do a little bit of simplification first, we can use other tests, p-series in this case, to figure out that our series diverges. So overall, root test, very bad idea for factorials. Ratio test, a much better idea, but there are some cases which the ratio test won't work.